Okay, let's go to section 5.3. So we're trying to solve his data management challenge. Your challenge from section 5.1 is to combine subject test scores into a single performance indicator for each student. So we want to combine them all the different grades. Grade each student from A to F based on their relative standing. So top 20%, next 20%, and so on, and sort the roster by student's last name followed by the first name. So we're going to do a double sort, sort of, and we learned about that before. A solution is given in the following listing. Okay, so this is chapter 5, which is in our class folder. So you can let's see, you can do this. You can copy this information and generate this data frame. Or of course you could type it out. So we have students, their names, then we have their math scores, science scores, English scores, and then we create a data frame with student, math, science, English, and we say strings as factors equals false, so that we don't, this is not turned into a factor, and we call it roster, our data frame. Okay, next thing we're going to do is give a variable z the following. So we're going to do scale, which we learned about, and we're going to apply scale to just columns 2 through 4, which are, the first column is student, so the second column is math, science, and English, 2 through 4. So let's see what that looks like. Okay, so remember that originally math was like big numbers, much bigger than 100. Science was these kinds of numbers, and English were these kinds of numbers. But now, look what we have. This is what scale has done. So it's taken the numbers and rescaled them so that they now are numbers between negative, what is it? Well, now, I'm sorry, they are now numbers centered at 0 with the so-called standard deviation of 1. So basically we've put them all on the same scale. So now they're comparable. And remember that our goal is to assign grades based on percentile, top 20%, next 20%, and so on. So we will, so we can perform this kind of rescaling, and it won't make any difference in terms of that kind of ranking. Okay, after we do this operation, now we do this. So what is this? This is the apply function, and we're applying it to our matrix Z, or actually it's a data frame, I guess, but our data frame Z, and we're applying it by row because this is 1, and we're getting the mean. So we're going to get each student's mean score, right, because we're applying the mean across the rows. So we're going to get the mean here, 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 and so on. So we're going to get the mean of all the 10 students. So let's try that. Let's try that. And let's see what we get. Now we should get a vector with 10 elements in it. Remember, this 7 means that this is the 7th element. This is the 8th, therefore the 9th and the 10th. Okay, now we have them. Now we have this, the mean scores, where we scaled the grades so that they were on the same scale. Okay, and now we're going to take our roster, we're going to take our data frame, and we're going to add to it, to roster, we're going to add score. So we'll redefine roster by adding score as well. So let's take a look at that. And now we will, let's see what it looks like. So now we have the original data plus their mean scores. Okay, remember this function? We did this before. We're going to use this now. So let's quickly review it before we use it. So let's review what happened. So this is how we used it. And last time I said, suppose we had, this was a vector with entries between 1 and 1,000. Let's try this again, because I think it would have been better to do 0 to 1,000.